Hi. Today we are going to learn about exploratory factor analysis. Before going for exploratory factor analysis, I received on questions from my students that about my previous videos about data normality and about data reliability. First question was that what is the range of Cronbach alpha reliability analysis? So the answer for this question is range of Cronbach alpha is between 0 and 1. The second question was that it is necessary to conduct normality test using Kolmogorov-Smirnov test and Shapiro-Wilk test, or it is okay to use skewness and kurtosis. I am going to give you the answer of this question. That according to Andy Field 2013 in his 4th edition book using discovering statistics using SPSS, he clearly wrote in his book that if you are going to analyze data whose sample size is less than 100, then you have to worry about your normality, and then you can use Shapiro-Wilk test. But if you are dealing with the large data set, if your sample size is large, like 400, 500, 600, thousands, then no need to conduct Shapiro-Wilk test. You simply use skewness and kurtosis and just calculate the z-score. The range of z-score is plus minus 1.96, plus minus 2.58, and plus minus 3.29 for different sample sizes, for example 100, 200 and 300. Okay, so today we are going to conduct exploratory factor analysis for the validity of the instrument. If you are going to develop your own instrument or you are going to adapt the questionnaire, so you have to perform the validity test, exploratory factor analysis. So before going for exploratory factor analysis, I want to clear some rule of thumbs that your data should fulfill those requirements, and you have to take some decisions. Since the study we are going to conduct is exploratory in nature, so there is a reason to identify the hidden variables that may be present within each domain to be taken forwarded for development for further analysis and future research. As a subsequent step, an exploratory factor analysis should be undertaken to identify to what extent your data could be comparable to your independent variable, dependent variable, and mediating and moderating variables according to their propositions and factor structures. All the items for your dependent, independent variables should bring into the variable box, and before this factor analysis, the following rule of thumbs and requirements for conducting factor analysis should be checked. The main purpose of the factor analysis is to allow the researchers to examine the set of variables in order to discover whether latent variables may exist which are relatively independent from each other. It is also used to reduce the number of variables and to identify any underlying or latent variables that may be present in the patterns of the correlations among measures. The first rule of thumb is related with the measurement issues, which suggests that items should be measured using interval scales. The second rule of thumb is that there is strong foundation need to support the assumption that there is factor exists before performing the factor analysis. The third rule of thumb is value of BTS exist among items. The fourth rule of thumb is Kaiser-Meyer-Alkin test KMO, which measures sampling adequacy. And remember, the value of KMO varies between 0 and 1. The value of KMO, if it is found 0.7, it is good, and if the value of KMO is less than 0.5, it is problematic. So Hutchison and Safoni in 1999 suggested that if value lies between 0.5 and 0.7, it is acceptable, and lies in medium range. If it lies in 0.7 and 0.8, it is good, but if it lies in 0.8 and 0.9 are considered very good. But KMO values having greater than 0.9 is superb or excellent. Another rule of thumb is suggested by Black in 2003. He suggested that sample size should be 300. The last criterion is the measurement of internal reliabilities, item total correlation, which is already noted in the reliability analysis. Apart from the requirements, researchers need to take decision whether which type of factor analysis to be used. There are two types of factor analysis: principal component analysis and principal excess factoring, and difference can be found the way they estimate the commonality. PCA is concerned with establishing which linear component exists within the data and how a particular variable may contribute to the component. On the other hand, PAF, principal access factoring, only estimates the underlying factors. The factor analysis establishes the commonality of each and every item, that is, proportion of its variance are explained by the factor it represents, and also the factor loading that measures the contribution made by an item to a particular factor. Factor analysis produces initial solution on a number of factors that may be present in a set of items, giving the eigenvalues of each that measure the amount the total variance accounted for by the factor. In this study, we will use the PCA, principal component analysis, to identify the latent construct underlying measures variables other than the data reduction. And another rule of thumb and decision need to be taken by the researcher that how many numbers of factors to retain. There are two criterion on the basis of which decision is made. One is Kaiser Criterion and second is graphical scree test. The Kaiser Criterion is to retain and select those factors having eigenvalues greater than 1. This is a proper decision when the number of items less than 30 and all the commonalities of the section are greater than 0.7, or when the sample size is greater than 250 and the mean commonality is greater or equal to 0.6. Graphical scree test is used to draw a graph, and it is appropriate when sample is more than 200. The third decision is factor rotation, which is to increase the factor loading of the items and interpretability of factors. Orthogonal rotation and oblique rotation are common methods. The first method produces factors which are independent of each other. The other allows factors to be correlated. In this study, we will use both orthogonal and oblique rotation for our variable. The steps should be considered with orthogonal rotation is PCA and Varimax, while for oblique rotation is direct Abelian and Promax. The last step is factor loading, which is degree of correlation between variables or factors. According to Hare et al., factor loading greater than plus minus 0.3 are considered as minimum level. Plus minus 4 are important and greater than 0.5 are significant. In this study, cutoff level plus minus 4 for factor loading is used as suggested by the Wozniak et Fiedel and Andyfield 2013. So here we have 18 items of for cognitive style indicator. There are three facets of cognitive style indicator. First is planning, and first is knowing, then second is planning, and third is creating. The first four items are for knowing, the 7 are for planning, and then the last 7 are for creating. So we are going to conduct the factor analysis now. Go to analyze and go to dimension reduction and factor. So bring all, we have to reset this one, bring all the factors into your variable box, these 18 items. So first of all, you have to go to your descriptive statistics. We need to calculate the KMO and Bartlett test of sphericity. The KMO value and Bartlett test of sphericity will tell you about the sampling efficacy. Extraction, we are going to check the scree plot, and you see eigenvalues greater than 1 based on eigenvalues, and principal component analysis is suggested. If you see, there are other factors, principal access factoring, there are other methods given, but we use the principal component analysis. And continue, and no need to go for these three options, just go and click OK. When I click OK, this is the initial unrotated solution. So remember, the factor analysis should be run at least 2 times or more than 2 times. So this is the first run. Here is the output. If you see, the Kaiser-Meyer-Alkin measure of sampling efficacy is 0.867, which is greater than 0.5, and the Bartlett test of sphericity is for 1217, and it is significant, so our first condition is met. Now go to the total variance explain, that is eigenvalues. If you see the eigenvalues here, the first factor eigenvalue is 6.2, the other is 1.8, 1.1 and 1.070. So in this table, total variance explained, 4 factors are retained, but if we go into the background of the variable, the theory allow us for the 3 factors, that is knowing, planning and creating. So he is suggesting that it is suggesting us the 4th variable. So we have to see whether this is true or not. And I want to tell you one thing, that in Andyfield book 2013 4th edition in Discovering Statistics Using SPSS, SPSS, and if it suggested that up to 0.7 we can retain factors, but the most authentic method is Kaiser Criterion, so we have to retain those factors whose value is greater than 1. So go to the scree plot. If you see that 1, 2 and 3, after 3 variables there is an elbow, that if we draw the graph, that this point is the elbow, this point is making the elbow. So if we go for 4, 5 and 6, here at 6 there is another a little bit inflection or elbow is made by these debris. So we don't go for the 6, 7 or 8 factors, we are going for the 3 factors. Okay, so now we are going to rotate the factors and go to analyze, dimension reduction and factor, and go to extraction method. And remember one thing, before factor analysis you should know the background of your variable. As I know the background of the variable cognitive style indicator, the theory of cognitive style indicator allow us for 3 factors, so I am going to use 3 here. And now rotation. So here you have to decide which methods to use. Varimax, Quantimax and Ecomax are for orthogonal, and direct ablement and Promax for direct ablement oblique rotation. So here first time I am going to use Varimax orthogonal method and continue. Go to options, sorted by size, suppressed coefficients. Here cutoff level is given 0.1, but in ND field book it is given 0.4. Factor loadings, your factor loadings will be the factor analysis will show you those items whose factor loadings are 0.4 or greater than 0.4. Those items with less than values factor loadings less than 0.3, it will discard by its own. Continue and click OK. Go to rotated component matrix. Here you can see that we have given the command to 3. This is the first factor. These factors, the items are making first factor. These are this is second factor and this is third factor. If you see in this table that there is an item 17, it fall in one factor, first factor, and also fall in third factor. And here is another item question 1, it falls in factor 1 and factor 2, and same is the factor 12, item 12 and item 11. This is called cross loading. So this is the these are the problematic items found in your data set or in your questionnaire. So we have to check, we have to delete these items, or we have to check these this questionnaire on direct ablement or oblique rotation. So we have to go to analyze and dimension reduction and factor. So in rotation you have to check the Promax and continue and OK. Promax and Varimax are used when there is no correlation, then Varimax should be used, and when there is correlation between the items, then we use Promax. Okay, so in Promax we don't go for rotated component matrix, it will produce pattern matrix. In pattern matrix we can see that there are 2 factors. There are 2 factors which are problematic, or which we can say there is a cross loading, 18 and 11. So you have to delete the one factor which has less factor loading. In this case we have the minus factor loading, so we can delete this one. And question number 18, analyze, dimension reduction and delete question number 18 and click OK. So go to pattern matrix and you can see there are again 2 items, question 17 and question 11. This is 510, 482, 405 and 505. This is less than, so we have to delete question number 17. Dimension reduction factor and question number 17 and click OK. Again you have to check the pattern matrix. There is one factor found problematic, 11, so we have to delete this 11 and again run the factor analysis until and unless you get the best solution for your factor analysis. So here is again 12 problematic, so we have to delete this 12. And again run. So You can see that there is no cross-loading in this dataset in pattern matrix. So these two items does not have their factor loadings. It means that their factor loading was less than 0.4. So XPSS has discarded these items. Also question 1. So we have adapted 18 items questionnaire. Now it is reduced to 1 2 3 4 5 6 7 8 9 10 11 items. So your questionnaire or our questionnaire is validated at 11 items, not on 18 items in my country context. So this is the factor analysis. I hope this helps you a lot, and thanks for watching this video. For regression, multiple regression, mediation, moderation, watch our next video. Thank you so much.